Howdy everybody, this is Dr. Thomas Coyle. Welcome back. I hope everybody's doing well. In this lecture I'd like to continue our discussion of the post-exam review for Exam 1, reviewing a few select questions, multiple choice questions on Exam 1, and covering them using my usual approach where I read the question stem out loud and then review the answer choices one by one, answering them true or false, and then arriving at the correct answer and telling you the correct answer. I beg you to pay careful attention to this post-exam review for Exam 1, in part because I want you to learn the information and to understand the information, but also for a more practical reason. The questions on Exam 1, and indeed on the next two exams, Exam 2 and 3, potentially could be seen again on the cumulative final exam. In any case, the cumulative final exam will cover everything discussed throughout the semester. And so you have to learn the information now so that you remember it later for the cumulative final and can answer the questions again if they're presented again on the cumulative final. So that's a good practical reason for paying attention, because you might see these questions again or variants of these questions again on the cumulative final, which by definition covers everything discussed since the very first day of class. Okay, so that's an overview. So I'm going to go through these questions. Now I've selected the questions to highlight certain issues that were addressed on the exam, a diverse range of issues. These questions were missed by some folks in the class, but not everybody, of course, and therefore were challenging for some folks. So again, I'll go through them. I'll give you the rationale behind them, the correct answer for them, and then we'll proceed using the same approach for each and every one. So let's start with the first item that you see on the current overhead, which focuses on attrition and lifespan longitudinal study. So it's always good to define terms in the question stem at the outset so you understand what they mean and therefore can orient yourself to the question. So we discussed this information, by the way, in the section on developmental research methods, where we covered the strengths and weaknesses of the two main developmental research designs, which were cross-sectional designs and longitudinal designs, which are being referenced here. And we talked about attrition when I discussed both types of designs, but it's a particularly relevant issue in longitudinal design. So what is attrition? Definition. In short, attrition occurs when subjects who are initially tested fail to return and be retested at a later point in time in a longitudinal study. Again, attrition occurs when a participant is initially tested but fails to return and be retested at a later point in time in a longitudinal study. Okay, and you might recall in a longitudinal study a single cohort of people is tested repeatedly and typically over an extended period of time, meaning months or years, okay, as opposed to days. And I gave you some examples of longitudinal studies. I think I gave you an example of a longitudinal memory study where a cohort of people was initially tested at age 10 years, then again at age 30 years, and then finally again at age 50 years to see how memory changed. Incidentally, a cohort, that's a key term. A cohort just refers to a group of people who are around the same age and who grew up in similar historical circumstances. So in longitudinal studies, you're basically following a cohort over an extended period of time and repeatedly testing them on a particular examination, on a particular test, or on a particular trait to see how it changes over time, to see how the trait changes over time. All right, so attrition again occurs when a participant who was initially tested fails to return and be retested at a later point in time in a longitudinal study. Effectively, and I didn't say this before, but I want to emphasize it now, attrition occurs when subjects drop out of a longitudinal study and fail to return to be retested. Again, attrition occurs when subjects drop out of a longitudinal study and fail to return to be retested. All right. And a problem, before I get to the answers, a problem with attrition is that the subjects who drop out and fail to be retested are not representative of people in the population. In particular, participants who drop out of a longitudinal study and fail to return to be retested are generally less healthy than people who remain in, and generally do more poorly on a variety of cognitive tests, such as memory tests or intelligence tests. So again, people who drop out are generally less healthy than those who remain in, and also generally do more poorly on a variety of tests, such as memory tests or IQ tests. Okay, and that in turn presents another problem, and the other problem is that if participants are not representative of a population, then the results based on the participants may not generalize to other people. And that's a big problem in psychology because a study is generally performed in order to make statements about a broader population based on the results obtained on the sample. Okay? All right, so I think that's enough background, so I'll read the question stem out loud, then we'll go through the answer choices one by one, answering them true or false, and then arriving at the correct final answer. So, beginning with the stem, attrition is a problem in lifespan longitudinal studies because A, participants that remain in such studies may not be representative of the population. That's true as well. So participants who drop out are not representative of the population, and participants that remain in such studies are also not representative. In fact, participants that remain in are generally more healthy than people who drop out. And they also generally do better on cognitive tests, such as memory tests and IQ tests, than people who drop out. That follows from what I said before. So A is true. Participants that remain in such studies may not be representative of the population. That is true. And if A is true, B has to be true as well. B is the results of such studies may not generalize to the general population. So if participants may not be representative of a population, then the results of studies based on those participants may not generalize to the general population. And if A is true and B is true, then the correct answer must be C, which is both A and B, meaning both A and B are true. D, of course, is not correct and should not have been selected. Neither A nor B are true. That's what D means, and that would mean A is false and B is false, and that's not the case because both A and B are true. C is the correct answer. Just FYI, just a little add-on to what I've said, attrition is a significant problem in longitudinal studies that last over an extended period of time, say several decades, because the healthy participants typically stay in the study and the less healthy participants typically drop out of the study or in fact die. Attrition is not a problem in cross-sectional studies, however, because in cross-sectional studies multiple cohorts of people are tested, and each individual in each cohort is tested only one time. So in cross-sectional studies, you have multiple age groups being tested. That's multiple cohorts. And each individual is in each cohort is tested only once, and therefore the individuals in each cohort are not asked to return to be retested, and therefore cannot drop out. And such studies, as a result, cannot show attrition. Cross-sectional studies cannot show attrition because participants are tested only once in cross-sectional studies, and therefore don't have the opportunity to drop out at a later point in time because they're not retested at a later point in time. Just a side note, but I thought it was worth mentioning now. Okay, that's the first question. Second question concerns cross-sectional designs. I just referenced cross-sectional designs. That's timely. And this particular item An item is simply a question. Concerns cross-sectional designs and the definition of cross-sectional designs as well as its strengths and weaknesses. So let's start off with a definition. Always start off with definitions. What is a cross-sectional design? In a cross-sectional design, multiple cohorts are tested around the same time, and each individual in a cohort is tested only once. Okay. Again, in cross-sectional designs, multiple cohorts are tested at the same time, and each individual in each cohort is tested only once. Okay. And again, a cohort basically refers to an age group. Okay. So more specifically, a cohort is a group of people who are around the same age, who were born at the same time, and who grew up in similar circumstances. But operationally, a cohort simply refers to a group of people who are the same age. So in a hypothetical cross-sectional design of memory, you might compare 10-year-olds to 30-year-olds to 50-year-olds. So you'd have a cohort of 10-year-olds, a second cohort of 30-year-olds, and a third cohort of 50-year-olds who are all recruited at the same time, who are all recruited in the same week. Okay, and then you'd compare them in terms of their performance on a memory test, for example. So in a cohort design, you're basically recruiting people in different age groups to typically be tested or evaluated on some psychological trait or characteristic. Okay, and looking for age differences, looking for differences between the different cohorts, between the different age groups which represent the cohorts. Now, let's see. Let me look at the answer choices and give you a bit of background. Yes. Okay. So the choices reference stability and also attrition. We just talked about attrition, but first some background. Before I get to the choices, let me give you some background on stability. Stability is a concept that we talked about in the section on research methods and longitudinal designs. I referenced it in cross-sectional designs too. Stability occurs when individuals maintain their rank order on a characteristic over time, critically over time, over an extended period of time. Again, stability occurs when individuals maintain their rank order on a characteristic over time. So stability would occur if individuals, for example, were given a memory test today and then were followed over time and given a memory test when they were, say, 30 years old, if they were 10 years initially, 30 years old, and then again at 50 years of age, okay? And stability would occur if the individuals who were given the memory test at age 10, then at age 30, then at age 50, maintain their rank order on the memory test, with the folks who scored high on the memory test at one particular period of time also scored high on the memory test at all other testing occasions. So stability would occur if the folks who scored high on the memory test at age 10 also scored high on the memory test at age 30 and 50, and conversely would occur if the folks who scored low on the memory test at age 10 also scored low on the memory test at age 30 and 50. So they'd be maintaining their rank order. Stability can only be assessed in a longitudinal design where people are tested on 2 or more occasions. So that happens in a longitudinal design. People are tested on 2 or more occasions, but doesn't happen in a cross-sectional design where people are tested on only one occasion. Okay. I didn't say that before for the previous question, but that turns out to be relevant. In a longitudinal design, a single cohort is tested on 2 or more occasions, typically over an extended period of time. And in order to address stability, you need to test the same cohort of people 2 or more times. But that only happens in a longitudinal study. It doesn't happen in a cross-sectional study where people are tested only once, and therefore stability cannot be examined in a cross-sectional study because cross-sectional studies only test participants one time, and you need to test participants 2 or more times in order to examine stability. In addition, cross-sectional designs cannot produce attrition. I said this before. The reason for that is because in a cross-sectional design, participants are only tested once, and therefore are not asked to return and be retested and can't drop out. Okay. Remember, attrition refers to subjects dropping out of a study at a later testing point. But in a cross-sectional study, participants are only tested one time and are not asked to return and be retested, and therefore cannot drop out at a later testing point. I think that's enough background. So let's read the STEM. The STEM is simply cross-sectional designs. The STEM is the initial part of the question. And let's go through the choices. So A, can examine the stability of psychological characteristics over the time. That's a big false. Stability can only be examined when participants are tested 2 or more times, which is what happens in a longitudinal study. Stability cannot be examined when participants are only tested 1 time, which is what happens in a cross-sectional study, as I said. So A is false. B, cross-sectional designs produce attrition at subsequent testing sessions. Also false. Attrition occurs, again, when subjects fail to return and be retested or drop out of a study at a later testing occasion. Attrition can only occur when subjects are tested 2 or more times and therefore have the opportunity to drop out of the study at a later point in time. But attrition cannot occur when subjects are only tested 1 time because they're not asked to return and be retested, and therefore they can't drop out. And so they can't drop out of a cross-sectional study because they're tested only once, and therefore cross-sectional studies cannot show attrition because subjects are tested once and therefore cannot drop out. So B is also false. C, involve testing 2 or more cohorts at the same time. That's parcel of the definition of a cross-sectional design. Again, in cross-sectional designs, 2 or more cohorts are tested at the same point in time, and each individual in each cohort is tested only once. So C is true, and C is the correct answer. C is the answer that you should have selected because it's the only correct answer there. It's the only true response. A is false, B is false, C is true, making C the correct answer, the one you should have selected. D and E are irrelevant here. D, again, is only 2 of the above are correct, but only C is correct, so you wouldn't pick D. And E, of course, is A, B, and C are correct. Well, that's not true either because only C is correct. So C is the correct answer for the reasons I said. And by the way, one more thing before going on to this question. I bolded it deliberately. I actually reviewed this question during the pre-exam review. The pre-exam review, of course, is the exam review before the exam. So I covered this question in the pre-exam review. And therefore, I hope everybody who's listening to this lecture actually reviewed the item in the pre-exam review and got it correct on the exam, since I reviewed it for the pre-exam review and told you the answer for the pre-exam review. And therefore, all you had to do, was remember the correct answer from the pre-exam review to get it right on the actual exam. So, but some people missed it. Go figure. So, what I'm saying, it's a little scold. I don't scold, by the way. I want you to do well in my class, but I want you to listen carefully to these lectures. I tend to test heavily on lectures, and the lectures, of course, include the pre-exam reviews, okay, which I'm referencing now, and the post-exam review, which I'm doing right now. Remember, to repeat, the cumulative exam will cover everything, and therefore some of these same concepts may be on the cumulative final, and you should follow this lecture carefully, if only because you might be hearing hearing about these same concepts again on the cumulative final, and maybe even seeing the same items again on the cumulative final. Okay. Alrighty. Next question. Yes, so the next question concerns prenatal screening procedures. So we talked about prenatal development and reviewed the 3 stages of prenatal development, the zygote, the embryonic stage, and then the fetal stage. Those are the 3 stages of prenatal development. And after that, we also reviewed some prenatal screening procedures, which included ultrasound, amniocentesis, and chorionic villus sampling. So there was a lecture on that, and lectures posted to Blackboard. And I talked about a few procedures. The one that's relevant here, it's being referenced here, is ultrasound. Ultrasound is one of the most commonly used prenatal screening procedures. Most pregnant women will undergo an ultrasound if they have insurance, or even if they don't. I suppose if they can get medical care in some other way, free of insurance, they'll undergo ultrasound. It's very common. Ultrasound is sometimes called sonography, which is also used in submarines to help the captains of the submarines navigate. And basically it works on the principle of emitting high-frequency sounds that are used to detect in the ocean various structures and objects, and to form an image on a screen of structures and objects. And in the case of pregnancy, ultrasound follows the similar procedure. In ultrasound in pregnancy, a probe is placed on a pregnant woman's stomach, and the probe emits high-frequency sounds. Those sounds bounce off of the developing organism, the fetus, and are used to form an image of the developing organism in the fetus, and provide a picture of the developing organism in fetus. So that image can be used to determine if there are twins, okay, or triplets, or quadruplets, or more. The image can also be used to identify the sex of the baby. The image can also be used to identify abnormalities during prenatal development. Might be physical abnormalities, something wrong, for example, with limbs, hands, arms, other structures, that sort of thing. And at a basic level, ultrasound can be used to confirm pregnancy very early on in the pregnancy. So ultrasound can be used for all those reasons, okay? But it works on the same principle as does sonography in a submarine. Again, in ultrasound in pregnancy, a probe is placed on a pregnant woman's stomach. The probe emits high-frequency sounds. The sounds bounce off of the developing organism and fetus and are used to form an image on a screen. And that image of the developing organism can do all the things I mentioned. Can be used to confirm pregnancy, confirm twins, and identify any defects or abnormalities, physical abnormalities. Alrighty. So I think I've given you the answer with all that. I should mention amniocentesis is the other one that's referenced in the choices. I'll go through the question in just a moment. Amniocentesis is another prenatal screening procedure. It's not routinely used in pregnancies, but might be used in high-risk cases where, for example, a pregnant woman has a history of genetic disorders in her family, or the father's family, and you want to screen for those. So in amniocentesis, you might recall, a small sample of amnion is extracted from the amniotic sac, and then the amnion is withdrawn and is analyzed for the presence or absence of genetic abnormalities. So that's amniocentesis is also referenced there, but amniocentesis again is not routinely used, whereas ultrasound is routinely used. Okay, so some background. Which technique would generally be used to confirm pregnancy and to determine if a pregnant woman was carrying twins? That's what the question stem says. This is a you know it or you don't. Of course, the answer is A, ultrasound. You wouldn't use amniocentesis for either of those things. Amniocentesis, again, is used to confirm the presence of genetic abnormalities after withdrawing amniotic fluid from the amniotic sac in a pregnancy, and then analyzing the amnion for the presence of genetic abnormalities. But you wouldn't use amniocentesis to confirm pregnancy or to determine if a pregnant woman was carrying twins. So B would be false, and therefore A is the correct answer. A is the answer you should select. Okay. Alrighty. Another bolded question. I bolded some of these questions just to indicate that the question was also covered during the pre-exam review. Yet, some students in my class still missed the question on the actual exam. I don't want that to happen. If I go over something clearly during the pre-exam review, if I go over an actual multiple choice question, I want you to get it correct. So I'm giving you a little hint. That is, during the next pre-exam review, that would be for exam number 2, please do go over the exam review carefully and review all the questions carefully so that you remember the answers during the exam and can get the answers correct no matter what, hopefully, but especially if the answers were actually mentioned in the pre-exam review. So this next question was mentioned in the pre-exam review, and now it's being mentioned again in the post-exam review, which is the review we're doing now. It's a question about Piaget and his stage theory and the assumptions of Piaget's theory. So there were two key assumptions of Piaget's theory, the so-called invariance assumption and the homogeneity assumption. The invariance assumption states that individuals should proceed through Piaget's stages in sequence, one by one, without skipping stages or regressing from a higher to a lower stage. Again, the invariance assumption states that individuals should proceed through Piaget's stages in lockstep sequence, one by one, without skipping stages and without regressing from a higher to a lower stage. So they shouldn't skip stages and they shouldn't regress from a higher to a lower stage either. The homogeneity assumption is the second assumption. That's not really relevant here, but just for completeness sake, the homogeneity assumption states that an individual in a particular stage should show thinking or reasoning characteristic of that stage on all problems and tasks that he or she solves. Again, homogeneity assumption states that an individual in a particular stage should show thinking and reasoning characteristic of that stage on all problems and tasks that she or he solves. So an individual in the sensory motor stage should show sensory motor thinking and reasoning on all problems and tasks that he or she is given. But that's not relevant. The one that is relevant here is going to be the invariance assumption. A key additional point about the invariance assumption is that although the assumption does clearly state that individuals should go through the stages in lockstep sequence, it does not assume that individuals should go through all stages and that all individuals should reach the formal operational stage. I mentioned that before, I'm mentioning it again. What it does assume is that people who go through Piaget's stages will go through them in sequence, okay, without skipping or regressing, not that people throughout the world everywhere will eventually reach formal operations. So effectively it's stating that people will go through the stages in sequence that they actually go through, not that they will all reach formal operations. Piaget argued that whether people reach formal operations or any higher level stages would depend critically on whether they had the necessary experiences in education to reach formal operations in higher stages. And some people would not have the necessary experiences or education to reach those stages, and therefore would not make it to formal operations. But the assumption is that the stages people do go through, they should go through in sequence. So if somebody is in the concrete operational stage, the invariance assumption would assume that they started in the sensory motor stage, then went directly into the pre-operational stage, and finally into the concrete operational stage where they stop. Okay, so I think that's enough background about Piaget's theory and the assumptions. So let's read the STEM out loud, then let's go through the choices. So which of the following are assumptions of Piaget's theory is the STEM? A, all individuals should reach the stage of formal operations. Well, that's false, and I just said it was false. That is not the assumption. The assumption is that the stages that people actually go through they should go through in sequence, not that they should go through all of them, including formal operations. So that's false. Whether you actually make it to formal operations, again, is going to depend on whether you have advanced experiences in reasoning to make it to formal operations, which is going to depend on training and education and instruction and other things that some people might get but other people won't. And those other people therefore won't make it to formal operations. A is false. It's not an assumption of Piaget's theory. B, all individuals should jump or skip stages. Well, that too is false. That directly contradicts the invariance assumption, which again states that individuals should go through the stages one by one in sequence without skipping stages and without regressing from higher to a lower stage, but that's false too. Okay, so A is false and B is false. B, both A and B, meaning both A and B are true. That's not correct because both A and B are false. D, neither A nor B are true, meaning A and B are false. And indeed, that is the correct answer, and that's the one you should have selected. D, neither A nor B is true. That is the case. A isn't true and B isn't true. Both of those are false, so D is the correct answer there. Okay. Again, this is a question that I actually covered during the pre-exam review, and that I was hoping, therefore, everybody would get correct. But some of you, only a small number, but anyway, some of you did miss it. Don't do that again. So for the subsequent exams, when I have the pre-exam review, please review the pre-exam review carefully. It sounds like double talk, but it's not. So that if you see the items in the pre-exam review on the subsequent exams, you get them correct. Alrighty. And another bolded one. So I guess I was doing this just to emphasize how important it is to go through these questions in the pre-exam review, because some of you were missing this. So this says children in the pre-operational stage of Piaget's theory. It starts out with that. It's called the STEM again. Pre-operational stage of Piaget's theory again is the second stage of Piaget's theory, generally occurring between 2 and 6 years of age in the United States. Remember, the age ranges I give you for each of Piaget's stages are ballpark age ranges for kids in the U.S., which can differ for kids in different countries depending on education, instruction, training, and other items. So it's the second stage, and so in the pre-operational stage, the kids have already learned object permanence in the sensory motor stage. Remember, in the pre-operational stage, the kids know everything they learned in the sensory motor stage, plus they know a few additional things. So in the pre-operational stage, the kids have learned about object permanence and understand object permanence because they knew that in the sensory motor stage. Plus, they also have a few new competencies, new abilities. For example, kids in the pre-operational stage, in addition to understanding object permanence, can also engage in symbolic play. Symbolic play occurs when kids use one object to symbolize or represent something else. So symbolic play might occur when a kid uses a broom to represent a horse, riding on a horse, or a broom to represent a rifle. Okay, those would be instances of symbolic play, also known as pretend play. And symbolic play is a new competence that is observed in this pre-operational stage. Okay, and that's why I'm referencing it here, because again, that's the stage of issue here. Another competency that is also observed in the pre-operational stage is the ability to form mental representations or memories of objects that cannot be seen. And indeed, that competency, I'm reading word for word, by the way, from B, that competency is actually observed initially in the sensory motor stage, in the latter part of the sensory motor stage, when kids acquire the ability to form mental representations of objects and people that are not seen, and therefore acquire an understanding of object permanence as a result. Remember, object permanence refers to the understanding that objects and people continue to exist even when they can't be seen. An understanding of object permanence occurs in the latter part of the sensory motor stage when kids acquire the ability to form mental representations. of objects that cannot be seen, and mental representations are critical to being able to form memories. Mental representations are just mental pictures in your mind of things. Mental representations of things you've seen in the past are memories. And kids who can acquire mental representations of objects that they've seen in the past also can acquire an understanding of object permanence and understand that objects and things that they can't currently see continue to exist, which is object permanence. And both of those things occur in the latter part of the sensory motor stage, which carries over into the pre-operational stage. Okay, I'm going through this because it's relevant to answering the question. I mentioned sensory motor kids can also do some other things. They can engage in symbolic play. They can also show evidence of deferred imitation or imitating something that they've seen in the past. Those are other competencies that are acquired in the pre-operational stage, but are not, in this particular case, being referenced in the question. This question actually references competencies that are acquired in the latter part of the sensory motor stage and then carry over into the pre-operational stage, where kids can continue to have these competencies in the pre-operational stage and acquire in addition some new competencies as well, symbolic play and deferred imitation. Okay, so that should be enough background to answer the item. It says, children in the pre-operational stage of Piaget's theory A understand that objects exist when they can't be directly perceived. That, of course, is true, and that's the definition of object permanence. Object permanence refers to an understanding that objects and people continue to exist when they can't be directly perceived, and that competency of object permanence is acquired in the latter part of the sensory motor stage and carries over into the pre-operational stage, where pre-operational kids can continue to understand object permanence and understand that their moms and dads and other people continue to exist when they can't be directly perceived. A is true. B, are able to form mental representations of objects that cannot be seen. That also is true, and that's basically a prerequisite to object permanence that is also acquired in the latter part of the sensory motor stage, and that also carries over into the pre-operational stage, where kids can continue to do it. So in the latter part of the sensory motor stage, kids are able to form mental representations or memories of objects that cannot be seen. Mental representations, again, are simply mental pictures of objects and things. In the latter part of the sensory motor stage, kids are able to form mental representations of objects and things that they've seen in the past, such as a mother or father who left the room and is no longer visible. And as a result, kids in the latter part of the sensory motor stage, can understand object permanence. And this competency, again, carries over into the pre-operational stage, the stage that's being referenced here. And you should keep in mind, by the way, that in Piaget's theory, all the competencies that are acquired in earlier stages in Piaget's theory carry over into the later stages of Piaget's theory. And in addition, kids in the later stages of Piaget's theory also acquire new competencies and new understandings. In the pre-operational stage, those new competencies and new understandings would include, as I've said before, symbolic play and deferred imitation. In addition to an understanding of object permanence and the ability to form mental representations of objects that cannot be seen, which carried over from the sensory motor stage. Okay, I think that's enough background. So let's read the question. STEM children in the pre-operational stage of Piaget's theory. A, understand that objects continue to exist when they can't be directly perceived. That's true. That's the definition of object permanence. Again, object permanence is acquired in the sensory motor stage and carries over into the pre-operational stage and all the other stages in Piaget's theory. B, are able to form mental representations of memories of objects that cannot be seen. That too is true, and that's a prerequisite to understanding object permanence. In order to understand object permanence, kids have to be able to form mental representations, that is, memories of objects that can't be seen. And if A is true and B is true, then the final answer, which you should have marked, is C, both A and B, meaning both A and B are correct. Okay. Yes. So this next item simply references correlations. the so-called correlation, by the way, or it's also called correlation coefficient. And I actually talked about this very issue in one of the lectures, and I gave you a similar question to the one that you see here in one of the previous lectures, so hopefully you got this correct. It's asking about a correlation. So a correlation is simply a statistic that is used to measure the strength and direction of a relationship between two variables. Correlation can be computed between SAT scores and college GPAs, and that correlation would measure the strength and direction of the relationship between SAT scores and GPAs. As it turns out, the correlation between SAT scores and GPAs is a positive correlation, and its magnitude is about around 0.4 or so, which means that knowing a person's SAT scores provides some basis for predicting their college GPAs. In particular, because it's positive, it means that increases in SAT scores obtained in high school are generally associated with higher GPAs earned in college. And conversely, it means that lower SAT scores obtained in high school are generally associated with lower college GPAs obtained later on. All right, so this is asking about the correlation, and you should know a few other things in order to answer it here. So you should know in particular about the range of the correlation, right? So I mentioned the range of a correlation is from -1 to +1. In addition to that, you should also know a thing or two about how to estimate or infer the magnitude of a correlation. I mentioned this in the lecture on correlation. In particular, the magnitude of the correlation is indicated by the absolute value of a correlation. The higher the absolute value of a correlation, the stronger the relationship between two variables. To get the absolute value of a correlation, a set of correlations, you would just make all the correlations positive, basically turn the negative correlations into positive correlations. And then to get the strongest correlation in the set, you would select the correlation with the highest absolute value. So again, mechanically, the easiest way to do that is to look at the set of correlations before you, change the negative correlations into positive correlations, and then select the correlation with the highest value. And that correlation, the one with the highest value, would represent the correlation that indicates the strongest relationship between two variables. So that's how you do it. And that's relevant to the question. If you look at the question stem, that's why I'm going through that. So with that info in mind, let's read the question stem, which says, which of the following correlations indicates the strongest relationship between two variables, irrespective of the direction or sign of the relationship? Okay. Strongest relationship, irrespective of the direction or sign. I put that parenthetical note in there because I wanted to make it absolutely clear that sign and direction was not relevant. I didn't really need to do that, by the way. That is, you could still answer the question correctly even without that parenthetical note, but that should have removed all doubt as to what I was asking. Okay, and then go through them. So again, the magnitude or the strength of the correlation, as it's being referenced here, is indicated by the absolute value of the correlation, with higher absolute value correlations indicating stronger relationships and lower absolute value correlations indicating weaker relationships. And to repeat what I said a moment ago, the easiest way to mechanically implement the process is to look at the set of correlations and then to convert them all in to absolute values by making the negative correlations positive, and then finally to select the one with the highest absolute value. And if you do that for these correlations, you should select D, and the reason for that is if you make all the negative correlations positive, you get the absolute value, and of course 0.7 is going to be the highest value correlation there. And 0.7, by the way, is a very strong negative correlation between two variables. So you generally find a negative correlation between, say, the amount of time you study for my exam and the number of errors you make on the exam. So it would be higher amounts of study time are associated with lower amounts of errors on the exam, and that would be a negative correlation. Anyways, the correct answer there is D, minus 0.7, because that is the correlation with the highest absolute value in the set of correlations being referenced there. By the way, 0 is an interesting correlation. A zero correlation indicates that there's no reliable relationship between two variables, and therefore indicates that knowing the value of one variable provides no information for predicting the value of the other variable. A good example of a zero correlation, the one that I gave, might be the correlation between IQ and shoe size. So knowing the value of an individual shoe size provides no basis for predicting their IQ. Okay, it's just a side note. The correct answer is D. Oh, look at this. Of course, I've reviewed these slides before going over them now, but I had forgotten that I actually referenced zero correlation, which in one of the questions, and I just covered zero correlation when reviewing the previous slide. So I think I gave you the answer. Zero correlation is a special type of correlation between two variables. A zero correlation indicates two things. First, it indicates that there's no reliable relationship between the two variables being correlated. And secondly, as a result, it indicates that knowing the value of one variable provides no basis for predicting the value of the other variable. The example of a zero-order correlation that I gave previously is relevant here again, and that would be the correlation between shoe size and IQ scores. There's no reliable relationship between a person's shoe size and knowing their IQ. And therefore, knowing the value of one's shoe size provides no basis for predicting the value of IQ, and therefore the correlation should be a big fat zero. Okay. Well, I just gave you the answer. A zero correlation indicates A, no reliable relationship between the correlated variables. That's just a know it or you don't. That's true. A is true. It's by definition what a zero correlation means. Correlations, by the way, indicate that one variable predicts another variable, and if there's a zero correlation, it indicates that there's no prediction at all between the two variables, no association or no relationship between two variables, which means that knowing the value of one variable provides no basis for predicting the value of the other variable. And this brings me to B, which I just referenced, which is also true, by the way. And B is knowing the value of one variable provides no basis for predicting the value of the other variable. Well, that's inferred from no reliable relationship. Okay, so B is also true. And if A is true and B is true, then the final answer is C. Both A and B are true. Okay. Yes, I think this is the last question, guys. It is. Let me go through it. So this is referencing the theory of fluid and crystallized intelligence. So Cattell and I mentioned fluid and crystallized intelligence when we talked about the assumptions of development in it's like the second lecture in the class. We talked about some key assumptions of development. One of those was that development involves gains and losses. Okay, that was one of the assumptions of development, that development involves gains and losses. There were others too, that development is a lifelong process, beginning at birth and ending at death, that development involves plasticity or the capacity for change, that there are multiple factors that influence development, social, cognitive, biological, and critically, going back to this question, that development involves gains and losses. Gains refer to improvements or in a trait or characteristic over time. Losses refer to decrements or deficits in a trait or characteristic over time. And I use the theory of fluid and crystallized intelligence to provide an example of that assumption, that development involves gains and losses. So theory of fluid and crystallized intelligence is a theory of intelligence proposed by Cattell and Horn. It proposes that there are two types of intelligence, fluid on one hand and crystallized on the other. These two types of intelligence refer to different things. So fluid intelligence refers to the ability to respond quickly to novel stimuli in the environment, and also to solve novel problems. So again, fluid intelligence refers to the ability to respond quickly to novel stimuli in the environment, and also the ability to solve novel problems. Novel problems, by the way, are problems that you haven't seen before, that you don't know the answer to, that are new. Novel means new, by the way. Okay, novel means new. And so that's fluid intelligence. And I gave you some examples of tests of fluid intelligence. A common example of a test of fluid intelligence is number series, where a participant like yourself may hear the beginning of a series of numbers and then ask to guess the one that comes next. So you might see, for example, the series beginning with sort of 1, then 4, then 9, and asked what comes next, and it would be 16. So I'm just squaring each integer as they go up. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and of course 4 squared is 16, so you should say 16 would be the next answer. I'm making that up, by the way, right now, but that would be sort of a type of item that you might find on a test of fluid intelligence, where you're being asked to reason about it. So fluid intelligence broadly refers to your ability to solve novel problems, but another way of thinking about it is it refers to your ability to reason effectively on novel problems, and including problems like the number series problem that I just mentioned. So that's fluid intelligence. Crystallized intelligence is the other type of intelligence referenced here. Crystallized intelligence refers to the ability to access knowledge for something you've already learned. Again, crystallized intelligence refers to the ability to access knowledge for something you've already learned. So crystallized intelligence is typically measured with tests of knowledge in courses like this or other courses, or tests of vocabulary. Words like avuncular, I mentioned that, avuncular, over, like, an uncle. Okay? So those are the two types of intelligence, and what's generally found and expected, I should say expected because I'm referencing what the theory is here. What's generally expected based on Cattell and Horn's theory of fluid and crystallized intelligence is that one of those two types of intelligence increases over the course of the lifespan, whereas the other type of intelligence is expected to decrease. Which we should know. In particular, the theory is that crystallized intelligence, or knowledge basically, increases over the course of the lifespan as you acquire new knowledge and as you're learning, whereas fluid intelligence is predicted to decrease over the course of the lifespan because you become slower at responding to novel stimuli and you reason less effectively on novel problems. And I think that, and by the way, those trends have largely been confirmed, okay, in actual research. So I just gave you the predictions, but there have been studies that have tested the predictions, and those studies have largely confirmed the predictions. So crystallized intelligence does increase over the course of the lifespan, and fluid intelligence generally decreases over the course of the lifespan. All right, with that in mind, we can answer the question. Let's start with the question stem. The theory of fluid and crystallized intelligence predicts that A, vocabulary knowledge should improve over the lifespan. That's true. The assumption is that you're learning new vocabulary words over the course of the lifespan, and therefore your crystallized intelligence is increasing over the course of the lifespan. B, responding quickly to novel reasoning problems should decline over the course of the lifespan. That's true as well. So in fact, that's part and parcel of the definition of fluid intelligence, which refers to the ability to respond quickly to novel stimuli and reason effectively on novel problems. And that decreases over the lifespan as people get slower over the lifespan. And by the way, there's excellent evidence really that people do get slower in responding to novel stimuli over the lifespan. Much of the evidence comes from simple reaction time studies involving participants of different ages over the lifespan, and people do generally get slower in responding to novel stimuli based on reaction time performances. So A is true and B is true, and if that's the case, the correct answer should be C, and that's the one that you should select there. That's the correct answer. Okay. Alrighty, so that is the last slide. I hope you enjoyed this post-exam review, and I hope you review it carefully, if only so you remember these items and remember these concepts so that you get them correct on the cumulative final if they come up again on the cumulative final. Okay, guys, thanks so much for listening to me. Appreciate it. Hope you enjoyed it. Take care.